Okay, gone ahead and I've solved a bunch more for this question. Don't forget we had just solved the wattage for the circuit was 4,388 watts. So that's already been done. So if we follow along, I got the order in which I completed these calculations in black marker. So starting with step one, I want to calculate my VA. I want to complete all the sides of that first triangle, the power factor of 0.7. So I take my wattage, I divide it by my power factor. I get a VA of 6,268.91. I made a note there for myself. That's at 0.7 power factor. Now I have my wattage, I have my VA, I can get my VARs. So VAR is going to be VA squared minus wattage squared. I get 4,476.89 VARs, and that's at 0.7 power factor. I have all three sides of that triangle. I go to my corrected triangle, my triangle with a 0.9 power factor. I already filled in 4,388 watts. That hasn't changed. Those are the characteristics of the motor. Motor's been built, it's constructed, that's how it's going to operate. So to calculate the VA, same steps as step one. So step three, 4,388 watts, this time divided by 0.9 power factor. So my VA is going to be much less. I have a VA of 4,875.82. Again, I made a note on that answer at 0.9 power factor. I write that in on the triangle. Step four, calculate the VARs of the new triangle. So VA squared minus my wattage squared, square root it. So those VARs will be 2,125.32, and that's at 0.9 power factor. So now I have two completely built triangles. All the sides are calculated. Don't forget the question wanted to know what size is the capacitor and VARs to correct to 0.9. So that'll be my last step. So I'm going to clean some of this up on the board, and I'll do my final calculation for A now that I have all my other answers. And then we can complete it by doing B, which will be the line current of the corrected triangle.